This is lesson 9, exercise 3J, solving simultaneous linear equations algebraically. So the previous exercise, we looked at solving it using our CAS calculators, which was the easy way. This one, solving it simultaneously using algebraic skills, is much trickier. Okay. So when we solve simultaneous equations algebraically, there are two methods that can be used. Either substitution or elimination. So we have this flow chart that can help us out in determining which method that we want to use. And using this flow chart, it will help us to solve for both x and y. We've just got to look at the simultaneous equations that we're working with and then determine which method we have to use based on specific prompts here. Okay, so I'm not going to read them out now. I'm actually going to jump straight to the first method, which is substitution, which is the first example. So when we solve simultaneous equations by substitution, the process is to substitute one variable from one equation into the other equation. So substitution itself is useful if one equation is in the form of y is equal to mx plus c, or some number with a positive or negative in front of the x, and then a variable that's added to the end. Okay, so m and c are just considered as numbers or constants in this case. Okay, so we're going to solve the pair of simultaneous equations y equals x minus 1 and 3x plus 2 is equal to 8. Now before I solve this, all this question is pretty much saying is that there are certain numbers that you plug in, x and y, that when you substitute it into here, it will give you a corresponding y value. But then also when you substitute those same x and y values into here and work them out, it should equal 8. And there's only one pair of unique numbers that can work for, okay? Because we can just substitute two random numbers to see if it works, but then when we substitute it back into the second equation, it has to obey the rule that when we multiply the x by 3 and the y value by 2, it has to give us 8, okay? So the way we're going to do this is through substitution. So we're going to go back to a little mind map here. Do both equations begin with y equals? In this case, one of them does, but the second one doesn't. So we're going to answer this as no. We're going to go to the next question. Does one equation begin with y equals? Well, in this case, yes it does. We have one of them here. This one doesn't, but this one does. Y equals. So we're going to answer this with yes. I'm going to keep going. We're going to substitute y equals equation into the other equation, and then we're going to solve. Okay. So on this side, the first thing I'm going to do, provided that this doesn't muck up, it's the first time I'm using this, we're going to write both equations. So y equals x minus 1, and this one here is equation number 1, and the second one is 3x plus 2y is equal to 8, and this here is our second equation. So you notice that in a different color, I'm labeling these equations. The first one is the first one, and obviously the second one is the second one, 1 and 2 respectively. Okay. So where it says here, we're going to substitute y equals into the other equation, all is saying that in this second equation here, we have a y, and in fact we have a 2y. Anywhere we see a y, we're going to substitute it with an x minus 1, because the first equation is saying that y is equal to x minus 1. And the reason why we want to do that is I want a new line that only has one variable in there, namely the variable x. Okay. So what I'm going to do is I'm going to write the next line, 3x plus 2. Then anywhere I see a y, I'm going to replace it with x minus 1. So in here, I'm just going to write x minus 1, close that bracket, and that's equal to 8. And using our algebraic skills, we're going to solve this equation. We're going to have to expand brackets, collect like terms, etc. until we get to a spot where we have x is equal to something. Okay, so the first part is 3x still. Now 2 times x is just 2x, and 2 times -1 is -2, and this is all equal to 8. Now, we want to get x by itself, but we're in a position where we have 2 sets of the letter x, 3 lots of them on one side and then 2 lots of them next to it. 3 lots of x plus 2 lots of x, we just have 5 lots of x. Okay, so that is collecting like terms. And then still have the subtract 2 is equal to 8. Okay. Now we're in a position where we're familiar with the actual equation itself, and we can solve for x. So we have a -2, so opposite of -2, or subtract 2 is +2, so we're going to add 2 to both sides. Cancel, cancel. We're left with just 5x on the left hand side. 8 plus 2 is equal to 10. And then with this, we have a 5 times x, so the opposite of times 5 is divide 5. So divide 5 left, divide 5 right. Cancel, cancel. X on the left hand side. And 10 over 5, or 10 divided by 5, is 2. Okay. Bit of a trickier process, or longer process in this case, but we have managed to get our x value, which is x is equal to 2. Now the second part to this is that we found x is equal to 2, but we also have to find the corresponding y value. And so all we're going to do is, with this answer x equals 2, we are going to, and I'm just going to draw a line to indicate that this is the next part, we are going to substitute, I'm just going to write sub for short, we're going to substitute x equals 2 into equation 1. Okay. The reason why we're doing this is because we have a template of some sort for equation 1, y is equal to x minus 1. So we can get our corresponding y value here based on the fact that we know what x is. In this case, x is equal to 2. So all I have to do is just substitute 2 into that equation. So instead of it being x minus 1, it's 2 minus 1. So our y value is 1. So we got our two values. X is equal to 2 and y is equal to 1, or 2, 1. Close bracket. So let's test this out. If our x value is 2, so when we substitute x equals to 2, 2 minus 1 should give us 1, which is the case here. And then when we substitute these sets of values into here, 3 times 2 is 6, and 2 times 1 is 2, meaning that 6 plus 2 gives us 8. So this set coordinates checks out and it works. Okay? Alright, we're going to do our second example now. Solve the pair of simultaneous equations y is equal to x plus 5 and y is equal to minus 3x plus 9. So again, we're going to look at our flow chart, this side here. Does both equations begin with y equals? In this case, it does. We have a y equals x plus 5 and another y equals minus 3x or negative 3x plus 9. So in this case, we're going to answer yes, and we're going to follow the instruction, make the equations equal to each other, and then solve. So what it means by that is it's saying because y is equal to x plus 5, and y is also equal to negative 3x plus 9, we can make them equal each other. So the first thing I'm going to do is write out each equation. So this is the first one, and then the second one equals negative 3x plus 9. label them again. Always get into the habit of labeling each equation. And what we're actually going to do is we're just going to state that 1 is also equal to 2. In other words, what we are saying is that x plus 5 is also equal to negative 3x plus 9. Because both of these are y, these two have to be equal to each other. X plus 5 is also the same as negative 3x plus 9, because both of these are equal to y. Okay, so we can say that one thing is the same as the other because of the equal sign. And what we're going to do now is just go ahead and solve for x. The only problem we run into is that we have x's on both sides. Okay, I don't like the fact that there is an x on this right hand side. Okay, and so what I'm going to do is, to get rid of it, I'm actually just going to add 3x. Okay, because adding 3x is the opposite of negative 3x. Okay, so I'm just going to add it, and what will happen is that will eliminate. Okay, if I have 3 lots of something and then I take away that 3 lots of something, I'm left with 0. Okay, but we can't just add 3x to one side. We also have to add 3x to the other side as well to compensate for the fact that we're adding 3x on the right hand side. So when we do this, this is going to cancel, this is going to cancel. I have an x, or 1 lot of x, and I'm going to add another 3 lots of x, so I'm left with 4x plus 5. And then on the right hand side, because these two have just cancelled out, because I forced it to be cancelled out, I'm just left with the plus 9, or in this case, a 9. Now we can go ahead and solve accordingly. We have a plus 5, so take away 5. 2 on the right hand side as well. Cancel, cancel. Left with the 4x on the left hand side. 9 minus 5 is 4. And in this case, we know that our x value has to be 1, because 4 times 1 is equal to 4. Okay, so cancel, cancel. X is equal to 4 divided by 4, which is 1. Okay, now we have x equals 1. We want to find the corresponding y value. In this case, we can either substitute it into equation 1 or 2. It doesn't matter because both of them has a y equals. But looking at the first equation, y equals x plus 5, it seems like the easiest one. So I'm just going to substitute it, sub x equals 1 into equation number 1. That will just make it nice and simple. So y is equal to 1 plus 5. So y is equal to 6. And that is our set of coordinates. X equals 1. And y is equal to 6. Double check. See if it works. When I plug in x equals 1 into here, 1 plus 5 is equal to 6, which is y equals 6. Yep, that works. And then when I substitute x equals 1 into here, we have negative 3 times 1, which is negative 3, plus the 9, we end up at positive 6, which is what we got here. So these coordinates here, they also work. Okay. This is just going to be the first part of 3J. There will be another recording for the second part. So go ahead and check the second video for the next set of questions or examples.